Hello and welcome. Today I'd like to introduce to you the WhaleTeq line of ECG test equipment, the SECG, the MECG and the CMRR test box. This line of equipment has been designed to help manufacturers and test labs perform tests against ECG standards such as those published by IEC and AMI. This particular video is to allow users to understand the scope of each item of equipment so that they can select which one is best for them. The SECG, or Single Channel ECG Test Unit, is intended for all types of ECG equipment, such as diagnostic, monitoring and ambulatory, and all types of ECG standards such as those published by the IEC and AMI. The equipment is intended for performance tests such as sensitivity and dynamic range, input impedance, frequency response using scans and impulse tests, input overload and saturation, multi-channel crosstalk, pacemaker rejection, heart rate accuracy, and special tests such as tall T-wave rejection, baseline drift, and minimum response. The hardware box contains resistor-capacitor networks as required by the standard, a precision low-noise floating DC offset of plus or minus 300 mV, relay switching, including allowing the user to select the output electrode, and 2 channels of voltage simulation, a low-level channel with up to plus or minus 5 mV with 14-bit 5 kHz resolution and 1% accuracy, and a high-level channel for pacing, overload and variable DC offset of up to plus or minus 1000 mV. The hardware is controlled by PC software via a USB connection. The PC software controls the relays and creates the waveforms using real-time streaming, allowing greater flexibility and resolution than a firmware solution. Although designed around IEC and AMI standards, the user has access to controls that allow testing well beyond the limits in the standard. In the SECG name, the term single channel simply means that the main test signal is a single channel, typically testing one lead at a time. It can be used for all types of ECGs, including multi-channel. The tests verify the full ECG system, including hardware and software. The SECG system itself, including its software, has been validated to confirm the accuracy of the dynamic signals, such as the shape of the test waveforms and pacemaker parameters. For periodic calibration, the user only needs to cover static voltages and component values. A software-assisted calibration mode is provided. The MECG, or Multi-Channel ECG Test Unit, is designed specifically for database tests such as CTS, CSE, AHA, MIT, ESC, CU and NS, as well as many databases available from the PhysioNet website. These databases can be found in standards such as IEC 60601-2-25, 2-47 and AMI EC 57. The databases require up to 8 independent channels of simulation, hence the name multi-channel. These 8 channels allow a full 12-lead ECG recording to be created. The MECG software can interface with various databases. Each database has both waveforms and reference values. For CTS, CSC databases, the waveforms are embedded in the MECG software. For PhysioNet waveforms such as MIT, ESC and CU, these are available for free from the PhysioNet website, while the AHA database must be purchased directly from ECRI at around $4,000. The reference values for the CTS waveforms are available in the standard. For CSE, it's necessary to purchase it from INSERM at a cost of $1,500. PhysioNet reference values are available again for free, while for the AHA it's included in the DVD. The MECG hardware has been optimized to provide high accuracy for both large and small values. This is necessary as some waveforms have a large peak amplitude but contain important low-level values such as voltages in the ST segment. DAC compensation and a digital reverse Wilson terminal for V1 to V6 have been used to achieve this goal. Generally, the target of a database test is to confirm the accuracy of analysis in the ECG software. These tests can take a long time to run in real time. As such, the standard allows the manufacturer to perform the test by digital simulation. However, sample tests using analog simulation can be used to validate the digital tests. This is not only good practice, but required in some standards. Also, for -2-25, there is a minimum of 2 tests that must be performed by analog simulation with a multi-channel simulator. There are 2 tests in the ECG standards that cannot be performed with the SECG or the MECG. These are the common mode rejection ratio or CMRR test and the baseline noise test. For these tests, the CMRR test box should be used. For CMRR, the box contains the 100 picofarad divider, double shield, imbalance impedance, DC offset and adjustable capacitor as required by the standard. It also contains a step-up transformer to obtain 20 volts RMS, a 1000-to-1 divider to monitor the floating 10 volts RMS, and an imbalance terminal instead of the switches in the standard. More detail on the CMRR test method and theory behind the test is provided in a separate video. For the baseline noise test, the box also contains the full 51K 47 nanofarad network as required by the standards. So that's it, a brief introduction of the 3 items of test equipment with enough information to help you select which units suit your needs. If you have any further questions, please feel free to contact WhaleTeq using the details shown. Thanks for your time.